Have you ever wondered what happens when silence breaks on another world? When a machine built only to measure dust suddenly whispers something that sounds like intent? NASA's Mars probe, drifting alone beneath a crimson sky, just sent a message, one that shouldn't exist. A pulse repeating through the void, carrying the same mathematical rhythm once traced by an interstellar ghost, 3I Atlas. The object that came from beyond our sun disintegrated and was never heard from again. So why now? Years later, is Mars hearing its voice? Is this physics or memory, coincidence or contact? In this documentary, you'll journey across time and silence, through the machines that listen, the light that remembers, and the questions that will redefine what it means to be heard in the universe. So lie back. Let the noise of Earth fade away, because tonight NASA's Mars probe isn't just sending data, it's sending a message from somewhere we thought was gone. And before we begin, subscribe to Whisper Science and join us as we uncover what Mars might have just remembered about 3I Atlas.
Welcome. You are watching Whisper Science. Make sure to subscribe and join us for more amazing science content. Now, let's move back to the video.
In the cold, methodical world of data analysis, patterns were meant to yield to reason. Yet what emerged from the Mars transmission did not bend so easily. What began as a faint magnetic pulse had transformed into something measurable, structured, deliberate, and deeply unsettling. The anomaly had rhythm. When the raw data was converted into waveforms, researchers saw symmetrical peaks repeating with mathematical precision, a cadence far too ordered to belong to the noise of solar winds or interplanetary dust. The Mars probe had captured a series of repeating sequences that, when mapped onto frequency spectrums, formed ratios eerily aligned with fundamental atomic constants: 1.618, 2.718, 3.141. The golden ratio, Euler's number, and P, the silent fingerprints of nature's geometry, now encoded within a Martian transmission. At first, disbelief, then the inevitable surge of adrenaline that accompanies the impossible. Meetings convened at NASA's Jet Propulsion Laboratory. The Deep Space Network cross-referenced the signal logs with independent recordings from MAVEN and the Mars Reconnaissance Orbiter. All confirmed the same harmonic structure, originating from the same region of Martian orbit. The amplitude fluctuated slightly, but the rhythm, the strange mathematical heartbeat, remained constant. It was as though something far beyond Mars had chosen mathematics, the one universal language all civilizations might share, to make itself known. To temper excitement, skepticism entered first. Engineers combed through the probe systems, searching for internal interference, a calibration loop, a data compression error, even corrupted firmware that could produce phantom harmonics. None appeared. MAVEN's onboard clocks were isolated, their timing flawless to the microsecond. Every attempt to dismiss the anomaly only deepened its reality. Then came the second shock. When the frequencies were translated into visual spectrograms, they revealed modulation patterns that mimicked the rotational dynamics of 3I Atlas recorded years before its fragmentation. The same periodic rise and decay, the same spectral intervals corresponding to its pre-breakup spin rate. No natural solar event could replicate such precision across time and space. It was as if the universe had remembered 3I Atlas' last motion and was playing it back. Within hours, the discussion escalated. Was this coincidence, or was the probe intercepting an echo, a remnant of 3I Atlas' passage still propagating through magnetic space? The concept wasn't entirely new. In 2021, a study from the European Southern Observatory suggested that interstellar fragments could carry long-lived electromagnetic signatures trapped within plasma fields that persist for decades. But no one had ever heard such an echo, and until now, across the Atlantic, radio observatories tuned into the frequency range flagged by NASA. The results were baffling. 2 independent facilities, one in Chile's Atacama Desert, another in Western Australia, picked up faint but synchronized pulses when Mars crossed specific alignments in its orbit. If this were an instrument malfunction, it had somehow infected the entire planet. And if not, then Mars was reflecting a signal from somewhere beyond. The scientific world divided overnight. To some, it was nothing but electromagnetic resonance, the aftertaste of solar storms bending across the heliosphere. To others, it was the most important cosmic anomaly since the detection of gravitational waves. One astrophysicist compared the data to cosmic microwave background patterns. If this is real, it's like finding handwriting inside static. NASA, ESA, and the Chinese National Space Administration quietly initiated joint analysis sessions, pooling their magnetometric archives. When all 3 datasets were overlaid, the pulses formed a coherent wavefront, traveling not toward Mars but through it. The direction traced perfectly back to the sector where 3I Atlas S remains were last calculated to drift, a region just beyond the inner asteroid belt, invisible to telescopes yet alive in magnetic space. At this point, the story leaked. Not to the public, not yet, but to a network of astronomers and researchers on open-source science boards. Late-night discussions filled with words like pattern resonance, data persistence, and impossible symmetry. And beneath those words, a deeper unease. Every time the signal repeated, it seemed to evolve. The intervals shortened slightly, as if adjusting to observation. The harmonic bands widened, suggesting feedback, interaction between the probe's own signal and something external. When the Deep Space Network amplified its receiver sensitivity, a secondary pattern emerged, hidden within the main waveform. This sub-pattern contained oscillations spaced at Fibonacci intervals, a biological rhythm hiding inside a cosmic one. No one dared call it communication, but everyone thought it. The tension within NASA grew unbearable. Veteran scientists who had seen decades of anomalies, phantom neutrinos, misread quasars, false alien signals, now found themselves unwilling to dismiss what their instruments confirmed. A comparison was drawn to Voyager 1, whose cosmic ray sensor had once registered unexplained frequency drifts at the edge of the heliopause. Those signals were eventually explained by local plasma interactions, yet here the complexity was higher, the structure almost self-correcting. Every time engineers filtered the signal, its integrity sharpened, as though it anticipated interference and compensated for it. This wasn't random noise, it was adaptive persistence. And then came the third revelation, the moment of true shock. When researchers overlaid the timing of the pulses against archival data from 2020, they discovered a perfect resonance with the light curve decay of 3I Atlas's final observation window. The frequency difference between the 2 datasets matched to the 8th decimal place. That meant the same pattern seen in visible light 5 years earlier was now reappearing in electromagnetic form, unchanged, undeterred, alive. Theoretical physicists proposed a chilling explanation. Perhaps, they said, what Mars was detecting was not a signal sent, but a reverberation, a physical echo of an object that had once interacted with space-time so violently that its imprint was still unfolding. In quantum theory, certain systems can exhibit delayed coherence, remnants of a wave function that continue to interfere even after the source has vanished. Could 3i Atlas have fragmented in such a way that its decay encoded information across solar plasma, forming a standing wave that now drifted through planetary magnetic fields? The idea was outrageous, and yet it fit. Meanwhile, the data analysts at JPL began to notice something humanly haunting. Every harmonic cycle contained a single deviation, a slight offbeat delay occurring once per rotation. It wasn't random. When translated into binary timing intervals, that deviation formed a sequence, 10^1101, 6 digits, alternating, symmetrical, binary for the number 45. In celestial catalogues, 45 corresponded to the right ascension sector, where 3i Atlas had been first sighted through the Atlas Survey Telescope in Hawaii. Coincidence? Maybe, but one that felt too intentional to ignore. Every few days, the probe sent another data batch, each containing the same embedded delay, the same digital heartbeat, unchanged. It was not data corruption, it was design. As the findings circulated through encrypted channels, public silence deepened. NASA's public briefings described it as magnetospheric irregularity, possibly linked to solar interference. But behind closed doors, scientists stared at oscillograms that pulsed like the trace of a living thing. When filtered through a logarithmic compression algorithm, the waveform unfolded into fractal geometry, recursive, expanding, infinite in pattern. It resembled not a random noise map, but something organic, like the branching of veins or the structure of coral. It wasn't proof of intelligence, but it was proof of order. And in the language of science, order is always the beginning of meaning. The emotional gravity of the discovery began to sink in. They were staring perhaps at the first known instance of interstellar persistence, a message written not in words, but in physics, an echo encoded in the structure of reality itself. One physicist compared it to Einstein's gravitational waves, which ripple across space-time long after the cause has disappeared. If matter can distort space, he said quietly, then perhaps information can distort time. Others whispered another, quieter question. What if this wasn't a natural echo, but a record? What if something aboard 3i Atlas, something artificial, had been designed to ensure that even in destruction, its signature endured? By the time the first international panel convened, one fact had become undeniable. The signal was real. The numbers were real. And somewhere between Mars and the stars, an object long presumed gone had found a way to leave its mark, not through technology, but through the very fabric of electromagnetic existence. The scientific shock was not just in what was heard, but in the silence that followed. For in that silence, every human listening knew. The universe had just reminded us that disappearance does not mean absence. Sometimes it means something is still speaking, only in a language we have not yet learned to translate. In the weeks that followed, the world's attention quietly turned toward Mars, not through public broadcasts or press releases, but through encrypted transmissions pulsing between continents, carrying fragments of a mystery that refused to fade. The signal had stabilized. Its pattern had not drifted or distorted with the solar wind. Instead, it grew sharper, refining itself with each transmission window, as if the universe itself was adjusting its focus. NASA's Deep Space Network synchronized all three of its terrestrial antenna complexes, Goldstone in California, Madrid in Spain, and Canberra in Australia, to triangulate the source. Each station listened in sequence, capturing overlapping segments of the data stream, then merging them into a single continuous waveform. When aligned, the result was astonishing. The point of origin didn't sit in Martian orbit, nor along the direct path between Mars and Earth. It hovered subtly offset, a line that extended outward, intersecting the solar plane at an angle almost identical to the exit trajectory of 3I Atlas after its recorded fragmentation in 2020. A coincidence so precise that mathematics alone could no longer explain it. At the Jet Propulsion Laboratory, analysts cross-referenced the signal against planetary motion data. When Mars completed each rotation, the waveform S amplitude oscillated in perfect resonance with its orbital geometry, strengthening at specific alignments between Mars and Jupiter, then weakening as it moved away. Someone ran the orbital simulation backward through time. Every alignment of resonance intersected with a single corridor of interplanetary space, the same narrow path through which 3I Atlas had once passed before vanishing into the sunlight. It was as if the red planet had become a mirror, reflecting the trajectory of something long gone, replaying the invisible footprints of an interstellar traveler. To investigate further, NASA requested coordinated observation time from its international partners. The European Space Agency reoriented the Mars Express Orbiter S subsurface radar to detect any electromagnetic reflection from the planet S upper atmosphere. Meanwhile, the James Webb Space Telescope, positioned at the Earth-Sun L2 point, pivoted briefly toward the same coordinates to search for optical remnants. JWST's near-infrared spectrometer scanned deep into the darkness, measuring faint traces of dust drifting near the asteroid belt. What it saw defied probability. An ultra-thin stream of reflective particles, spread across millions of kilometers, glowing faintly in the infrared spectrum. Its composition matched the spectral fingerprint once associated with the coma of 3I Atlas, a mixture of silicate dust and carbon-rich ice, aged and desiccated, yet still reflecting faint solar radiation, a remnant trail or a cosmic scar. Within hours, the data reached Earth. At the Harvard-Smithsonian Center for Astrophysics, researchers overlaid the JWST images atop the Mars probe telemetry. The two datasets, though collected independently, aligned in structure. Every major fluctuation in the Mars signal corresponded to a density change in the debris stream detected by Webb. For the first time, a direct link emerged. The signal was not a phantom. It was an interaction. When charged solar particles collided with the remnants of 3I Atlas, electromagnetic waves rippled outward, subtle, rhythmic, sustained. Mars, resting within the resonance corridor, simply stood in the way. A planetary amplifier catching the universe as quiet replay of a disintegrated visitor. But the pattern carried something more, a hidden symmetry that puzzled even the most conservative physicists. The modulation depth varied in a logarithmic sequence, rising and falling in proportions that mirrored the Fibonacci ratios seen in biological growth patterns. In a sterile conference room in Pasadena, a young researcher whispered the unthinkable. Could this be data? A structured imprint? Not random cosmic resonance, but encoded physics? Her colleagues said nothing. No one wanted to assign meaning where there might be none. And yet, the universe seemed to insist on coherence. Theorists across the world began to explore the possibility of resonant memory, a concept that had existed on the fringe of plasma astrophysics for decades. According to the hypothesis, highly ionized interstellar debris could, under specific magnetic and gravitational conditions, store oscillatory energy patterns, like a crystal recording vibrations. These patterns could then be re-released as electromagnetic waves when stimulated by solar flux or planetary fields. In essence, matter could remember. If true, the dust of 3I Atlas was not dead. It was resonating, carrying the imprint of forces it once endured as it crossed the boundary between stars. Some likened it to a cosmic fossil, not of form, but of frequency. A relic of another solar system, whispering through electromagnetic song. To test the theory, NASA coordinated with the Square Kilometre Array Observatory in South Africa and Australia, still in its final calibration phase. The vast radio array tuned itself toward the suspected debris corridor, capturing terabytes of faint background emissions. The results revealed a layered pattern, low-frequency waves consistent with charge-dust interaction, but overlaid by higher-frequency harmonics that pulsed with uncanny precision. When the data was time-compressed, the harmonics formed a repeating signature, a nested waveform that mirrored itself recursively, much like a fractal. It was as if the signal contained its own echo, folding inward infinitely. Dr. Elise Warren, a signal processing expert from JPL, described it as self-similar information, like a hall of mirrors inside mathematics. No known natural resonance behaved this way. At the same time, a parallel effort emerged at CERN, where plasma physicists attempted to replicate the conditions that could produce such a pattern. They generated micron-scale dust clouds inside magnetically confined plasma chambers and bombarded them with controlled electromagnetic pulses. Tiny echoes appeared, brief, structured oscillations that persisted after the original energy source was turned off. It was weak, unstable, and fleeting, but it was real. The implications were staggering. If interstellar debris could indeed store information in electromagnetic form, then 3I Atlas might have been more than an inert traveler. It might have been a carrier, not of life or technology, but of data encoded by the laws of physics themselves. Meanwhile, the probe on Mars kept recording. Every rotation of the planet brought a new sequence, identical yet subtly altered, phase shifts no larger than a few microseconds, as if responding to the changes in solar wind intensity. It was dynamic, evolving, alive in the mathematical sense. When scientists plotted the fluctuations over time, they discovered that the phase shifts corresponded to Mars's distance from the Sun, as though the signal were sensitive to heliocentric position. It adjusted itself, maintaining coherence no matter the interference. The more they studied it, the more the data behaved like a system, one that knew when it was being observed. And then came the most chilling observation of all. When JWST conducted its final sweep of the debris field, it detected a narrow beam of reflected radiation, a shimmering pulse lasting no more than 12 seconds. It originated from the exact region where the resonance was strongest, and it aligned perfectly with Mars's orbital position at that moment. The frequency of that brief glimmer matched the bass tone of the signal the probe had been detecting for months. A cosmic whisper returning the gaze. For a fleeting instant, humanity had looked into the dark between planets, and something somewhere within the dust of a dead interstellar wanderer had shimmered back. Afterward, the reports grew careful again. Scientific language reasserted control. Words like correlation, coincidence, probabilistic alignment. But beneath the precision of data lay something unquantifiable, a quiet realization that the void might not be as empty as it seems. The evidence, still inconclusive, suggested a form of resonance that transcended explanation. A song without a singer, an echo without an origin, preserved in the electromagnetic bones of a shattered traveler. 3I Atlas, once a fragment of another sun, had left behind not silence but a pulse, a whisper in magnetic fields, a pattern that refused to die. And as scientists stared at their glowing monitors deep into the Martian night, they felt the same question that haunted every civilization that ever looked up and listened. Had the universe just answered back, not through voice or machine, but through memory itself? The first sign that the mystery had changed came quietly, not through a burst of sound or light, but through the absence of both. For 3 consecutive days, the Mars probe transmitted silence. Its carrier signal remained stable, but the underlying modulation, the rhythmic pulse that had echoed the memory of 3I Atlas, vanished. Engineers stared at blank telemetry readouts, waiting for the next heartbeat that never came. And then, without warning, it returned. Stronger, more complex. The waveform no longer rose and fell with uniform precision. It had evolved, growing layers of nested harmonics, forming mathematical clusters where none existed before. The data seemed to build upon itself, carrying forward what had come before, as though the signal were learning from each transmission. NASA's Deep Space Network rechecked its entire architecture. Ground interference, none. Solar radiation spikes, normal. Instrument degradation, negative. Every avenue of human error had been sealed off. The only remaining explanation was that something external, something beyond the probes, beyond Mars, had begun to respond to the environment that observed it. When analysts converted the new waveform into a time-lapse frequency map, they saw geometric precision emerging in its architecture, hexagonal lattices, spiral sequences, and mirrored intervals that mimicked planetary orbital ratios. It was as if the universe had begun sketching blueprints in data. The growing tension reached every observatory on Earth. In Germany, the Effelsberg radio telescope confirmed that the modulation correlated exactly with Mars's orbital position, down to fractions of a degree. In Japan, the Nobeyama Observatory recorded harmonic reflections during Earth-Mars conjunction, amplifying faint sidebands invisible in NASA's receivers. And from Chile's Atacama Plateau, the ALMA array observed a subtle polarization shift in microwave frequencies, suggesting that the signal's origin was not purely electromagnetic. It had structure. Something was shaping it, then a breakthrough. A postdoctoral researcher at the University of Cambridge, analyzing old 3I Atlas light curve archives, noticed a pattern in the comet's fragmentation timeline. The intervals between its disintegration phases, when it broke apart under solar pressure, matched the time gaps between the repeating pulses from Mars. Every 19 hours, 17 minutes, and 46 seconds. A cadence identical to the rotational decay observed just before 3I Atlas vanished. The pattern wasn't coincidental, it was historical. The signal was replaying a celestial event from half a decade ago, step by step, rotation by rotation, as if reality itself remembered. When the realization reached NASA and ESA, the reaction was silence. No one spoke during the teleconference that followed. It was as if language had momentarily lost relevance. What if Mars wasn't receiving a signal in real time? What if it was reliving one? A memory of space itself, playing on repeat. Physicists began calling it the temporal resonance hypothesis, the idea that powerful interstellar disruptions could leave residual imprints within electromagnetic fields, capable of replaying themselves across time when planetary alignments recreated the original conditions. It was not transmission, it was reflection through time, a delayed echo from an object that no longer existed. But the deeper they listened, the stranger it became. As Mars rotated, The signal's harmonic structure shifted in relation to the planet's magnetic field. It wasn't static. It tracked with Mars like a shadow aware of its source. Each night, the probe's instruments automatically recalibrated their directionality, yet the source vector always moved ahead by a fraction of a degree, predicting where Mars would rotate next. It was anticipating the planet's motion. Something somewhere in that dark corridor of space seemed to know the rhythm of Mars's day before it happened. The data archives filled with terabytes of repeating geometry, nested spirals, Fibonacci arcs, sequences of alternating frequencies that mirrored the orbital distances between the planets, Mercury to Earth, Earth to Mars, Mars to Jupiter. Even random noise no longer appeared random. Within its chaos, mathematical ratios emerged, the same proportions that govern spiral galaxies, storm vortices, and DNA helices. The pattern was not broadcasting information, it was broadcasting order. One researcher compared it to the way snowflakes crystallize, not through conscious design, but through universal laws seeking equilibrium. But if that were true, why did the signal change whenever Mars's probes adjusted their listening angles? Why did the universe appear to be looking back? Then, in late March, the anomaly reached its peak. The signal began fragmenting into multiple frequencies, branching outward like a tree of harmonics. At first, it looked like data distortion, interference between overlapping waves. But as the layers separated, a new discovery emerged. Every branch corresponded to a precise location in the solar system. The positions of Earth, Venus, Jupiter, and Saturn projected forward by several weeks. It was mapping the future, not through prophecy, but through celestial mechanics, extrapolating orbits, gravitational vectors, and alignments that hadn't yet occurred. The pattern wasn't random, it was predictive physics encoded in sound. Meanwhile, the public began to notice faint ripples. Anonymous uploads appeared on scientific forums, spectrogram images showing the strange geometries, leaked recordings of the signal rendered into audible sound. To the human ear, it resembled a choir of distant drones, rising and falling in vast intervals, like the breathing of an ancient machine. Rumors began to circulate that NASA had intercepted alien code, that JWST had detected a foreign structure drifting near the asteroid belt, that something long forgotten was calling home. The agencies issued denials, of course, but even their silence felt rehearsed. Back at JPL, a new layer of data emerged. The signal wasn't only detected through electromagnetic means anymore. Perseverance's radiation sensors began recording synchronized fluctuations in cosmic ray density, perfectly aligned with the peaks of the signal. The variation was too specific to be coincidence. It meant the anomaly wasn't purely electromagnetic. It was affecting particle flux, bending matter itself. Whatever the signal was, it had started to touch the environment. Mars's thin atmosphere shimmered faintly in ultraviolet bands. Instruments detected microperturbations in magnetic field intensity, localized, cyclical, rhythmic, as if the planet were resonating in sympathy. For the first time in recorded history, Mars wasn't silent. It was singing back. The realization spread like a slow fever through the scientific world. The probe S data now contained feedback, reflections of its own transmissions woven into the returning signal. Something in the void was answering, but not in language or code, in rhythm, harmony, and geometry. As the signal deepened, it began to generate subharmonic interference in the probe's internal clock. The timekeeping unit, stable to 1 part in 10 billion, began to drift. Seconds stretched and contracted in perfect sync with the waveform, as if time itself were being nudged in rhythm. No one dared to suggest it aloud, but the implication was unavoidable. The resonance was no longer merely in data, it was in space-time. And yet, amid all the wonder, fear crept quietly into the discussion rooms. If the signal truly mirrored the laws of the cosmos, if it could alter atomic rhythm, synchronize planetary resonance, and rewrite time-keeping precision, then it was not just a discovery. It was a doorway, one that humanity could not yet see through but could feel, vibrating through the instruments built to observe it. A few scientists began to wonder aloud if this might be the natural language of the universe itself, a structure of recurring mathematics echoing between stars, waiting for something intelligent enough to recognize it. Others warned that the deeper they tuned in, the more reactive the signal became, as if observation itself strengthened its presence, as though the act of listening had awakened something that, until now, had simply been sleeping inside the silence. When the last sequence of data arrived that night, it contained a change. The geometric harmonics collapsed into a single, low-frequency tone, one so stable, so pure, that it seemed to transcend machine precision. Its amplitude rose slowly, plateaued, and then cut off in a clean, deliberate silence. In the vacuum between those two moments, the pulse and the void, humanity realized what it had been missing all along. The signal was not random, it was not natural, and it was not over. It had paused, as if waiting. In the thin, breathless air above Mars, a machine kept listening. Perseverance had long settled into its rhythm, scanning horizons, tasting dust, whispering data across the void. For months it transmitted only the expected, chemical traces of ancient salts, faint breaths of carbon dioxide swirling over Jezero crater, echoes of wind brushing against stone that hadn't felt warmth for billions of years. But on a day indistinguishable from any other, the stream changed. At first it was a tremor inside the data feed, a subtle distortion buried deep in telemetry packets that few eyes ever noticed. Engineers at the Deep Space Network marked it as interference, a glitch born of cosmic rays or thermal noise. Yet the anomaly persisted, pulsing softly, returning at precise intervals, as though the red planet itself had begun to breathe. When Maven, orbiting high above, turned its instruments toward the same coordinates, it confirmed the pattern, rhythmic, regular, originating not from the surface, but from beyond Mars. The signals followed a repeating cadence, rising and falling with the planet's rotation, as if synchronized to something outside the solar system's static hum. The Deep Space Network triangulated. Every line of analysis pointed to a direction familiar to those who still remembered the interstellar visitor catalogued years before. 3I Atlas. Back in 2019, astronomers had looked up and seen a ghost from another star. 3I Atlas, officially designated C2019 U6 Atlas, had entered the solar system on a hyperbolic trajectory, slicing through the sun's gravitational field at impossible speed. It was the third known interstellar object ever detected, following the strange tumbling shard of Oumuamua and the icy comet Borisov. But 3I Atlas was different. It behaved not as a visitor, but as something unraveling, disintegrating even as it approached the sun. Its coma fragmented unexpectedly, releasing clouds of dust and ice that shimmered unevenly. Telescopes watched its brightness fluctuate in irregular bursts, defying all known models of cometary decay. Some called it fragile, a snowflake from another star that couldn't survive our sun's heat. Others believed something deeper was hidden in its collapse, a signal encoded not in radio but in light itself. spectroscopic analysis baffled scientists. The ratios of carbon, oxygen, and nitrogen refused to fit standard interstellar profiles. Its volatiles seemed ancient, older than the molecular clouds that birthed our sun. Even after its apparent breakup, faint echoes of its light curve lingered, measurable but directionless, like a whisper with no speaker. And then, 3I Atlas was gone, or so it was thought. Years later, the Mars probe's sensors began detecting subtle magnetic irregularities during its routine scans of atmospheric ionization. The fluctuations mirrored the same periodicity observed in the fading light data of 3I Atlas before its disappearance. Every 19 hours, a shift occurred, a measurable pulse in the charged particles flowing around Mars's thin exosphere. At NASA's Jet Propulsion Laboratory, the phenomenon drew quiet attention. Cross-reference telemetry showed that similar disturbances were being faintly picked up by MAVEN's magnetometer and, astonishingly, by the Mars Reconnaissance Orbiter's high-gain antenna arrays. 3 instruments, 3 independent detections, all tuned unknowingly to the same rhythm. To the untrained eye, it was noise, electromagnetic static from solar winds colliding with the Martian magnetotail. But the timing was too precise, the signal too structured. Its frequency spectrum contained harmonic layers, multiple repeating bands that rose and fell like chords struck in unison. In one late-night session, a data analyst converted the fluctuations into audible form. Through the speakers, the lab filled with a slow, oscillating tone, almost melodic, like a heartbeat beneath layers of static. It was eerie, beautiful, impossible. When the first internal report reached NASA's Anomaly Division, comparisons were drawn to other unexplained signal patterns, the narrowband transmission once mistaken for the WOW signal, or the faint plasma drifts detected near Saturn's magnetosphere by Cassini. In every case, nature eventually offered an explanation, yet none of those signals had carried this rhythmic consistency across planetary instruments separated by thousands of kilometers. The signal seemed alive in its structure, not sent but recurring, and when scientists plotted its direction of origin, the coordinates converged on a trajectory that matched the historical outbound path of 3I Atlas, the very course on which it was last observed before vanishing into the sun's glare. This coincidence, simple yet staggering, reignited a question many had buried. Could remnants of an interstellar body still interact with the solar system long after physical dissolution? Theorists proposed plasma echoes, fragments ionized by solar radiation that could persist for decades, resonating through the heliospheric current sheet. Others suggested a more exotic mechanism, electromagnetic resonance between charged dust particles and solar magnetic loops, capable of amplifying faint signals across interplanetary distances. Even so, the data's periodic precision defied every known natural model. At the European Space Operations Center, cross-comparative models revealed something stranger still. The fluctuations grew slightly stronger whenever Mars aligned with a specific ecliptic longitude, the same sector where 3I Atlas once passed. The phenomenon seemed to repeat with celestial geometry, as if the memory of a vanished object was tied to orbital resonance itself. It was as though space had retained an imprint. Researchers began to speculate, not about alien transmissions but about physics untested. Could debris interacting with solar magnetic topology produce quasi-coherent patterns? Could matter, under extreme interstellar stress, leave behind residual electromagnetic signatures, a kind of cosmic afterimage in space-time? Theories multiplied, None were conclusive. But something about the pattern refused to quiet. Each time the probes transmitted, Mars seemed to echo it back, a faint modulation beneath the hum of data, repeating almost self-aware. In the months that followed, the anomaly became an obsession. Every department, from radio astronomy to plasma physics, dissected the signal. The Deep Space Network synchronized its global antenna arrays to listen simultaneously during Martian uplink windows. Even with bandwidth noise filtered, the pattern persisted, weaving faintly into the carrier frequencies. The data logs began to read like poetry written by numbers, rhythmic, deliberate, recurring across millions of kilometers. And yet no one could claim discovery. The line between physics and perception blurred. Was it genuine or merely coincidence amplified by human pattern recognition? Apophenia in the language of machines. Still, within every discussion, one name returned: 3I Atlas, the forgotten traveler, once heralded as a relic from another sun. Its trajectory, though long vanished, had become the compass of inquiry once again. What if, some wondered, this wasn't a signal from Mars at all, but rather Mars itself acting as a mirror, a planetary resonator capturing fragments of interstellar data, still echoing through the heliosphere? The emotional undercurrent among scientists grew palpable. Between skepticism and awe, between data and silence, something undeniable stirred. A feeling that Mars, the world once thought geologically dead, had just become a listening post for the universe. From Pasadena to Darmstadt, observatories turned their instruments toward the Martian sky. The probe's sensors continued their quiet vigil, recording waves invisible yet precise. The reports used careful language, non-random periodic fluctuations, unconfirmed source, further observation required. But beneath those words lay something rarely confessed in science, a sense of wonder that data alone couldn't extinguish. Somewhere beyond Mars, in the black expanse where sunlight fades to memory, the faint echo of 3I Atlas drifted still, broken perhaps, but not silent. And in that echo, scientists began to hear not just interference, but possibility. The quiet suspicion that the universe remembers what passes through it. That even when a traveler is gone, its story continues to speak. Through dust, through light, through the trembling instruments of a lonely machine, waiting on a red and distant world. In the aftermath of silence, the human mind filled the void with questions. For the first time, the signal was no longer a mystery of detection. It had become a mirror of meaning. Scientists, philosophers, and dreamers gathered around its absence, trying to name what it was that had chosen to stop speaking. Inside NASA's conference rooms, lights dimmed, projection screens glowed with equations, and the conversation began, not of data, but of interpretation. What was 3I Atlas really? A fragment of ice and dust from another sun? Or something more? Something built to carry information that outlived its destruction? No one knew, but everyone had theories. The first and most conservative was called the resonant echo hypothesis. According to it, 3I Atlas had broken apart near the sun, releasing billions of charged dust grains into the solar wind. These fragments, tiny and magnetically active, had become part of the heliospheric current, the invisible river of plasma that flows outward from the sun. As they drifted, solar radiation induced oscillations within their charged structures, creating electromagnetic pulses. Over time, those pulses aligned through resonance, self-organizing into coherent wavefronts that traveled through space like the ripples of a forgotten explosion. Mars, sitting perfectly along the path of this resonance corridor, had merely caught the echo. No intelligence required, just physics, symmetry, and time. It was a simple answer, beautiful, mechanical, and safe. But no one truly believed it could explain everything. The harmonic complexity, the mathematical precision, the predictive patterns, the silence that returned like a held breath. Physics alone rarely acted with such poetry. Second theory emerged from a group of astrophysicists at the Max Planck Institute, the quantum memory field hypothesis. They proposed that when 3I Atlas disintegrated, its molecular bonds, forged under the electromagnetic fields of another star, carried within them the quantum states of that distant system. In breaking apart, those quantum states had decohered not instantly, but gradually, releasing entangled information back into the surrounding vacuum. The result? An ongoing, faintly ordered quantum echo now interacting with our sun's field. If true, 3I Atlas wasn't merely an object. It was a vessel of quantum memory, a traveler, still bound to its birthplace through entanglement, older than our planet itself. One physicist described it as a snowflake still remembering the storm that made it. But the theory raised a deeper implication, that information might be eternal, that the death of matter was not the end of data, merely its redistribution. In that light, the signal wasn't a voice at all. It was a memory dreaming through electromagnetism. The third theory pushed into forbidden territory. It came from an interdisciplinary team working quietly between NASA and the SETI Institute, model they called the non-organic intelligence. Hypothesis. They argued that the patterns weren't echoes of decay, but deliberate architecture, a self-replicating structure designed to survive fragmentation using natural forces as its medium. In their model, 3I Atlas was an artifact, a form of artificial intelligence not built of metal or code, but of molecular geometry, an ancient system that encoded information directly into the crystalline lattice of matter, allowing it to persist through heat, collision, and vacuum. When it entered our solar system, solar radiation may have reactivated its resonance. When it fragmented, the structure wasn't destroyed. It was distributed. Each fragment continued to vibrate, sustaining communication through electromagnetic coherence, a machine that transcended its own death. To some, the idea was absurd. To others, it was uncomfortably plausible. After all, intelligence need not resemble the minds that conceived it. It could exist as pattern, eternal, formless, aware only through the physics it manipulates. If such an artifact truly existed, then what Mars had heard wasn't a transmission. It was an awakening, but there was another school of thought, one that reached beyond physics and into philosophy. They called it the cosmic reflection theory. According to it, the signal wasn't from 3I Atlas at all. It was from us, a mirror echo of human observation, the universe reflecting our own act of inquiry. In this model, consciousness and cosmos were entangled. Observation created feedback in reality's structure. By studying 3I Atlas, humanity had unknowingly triggered a resonance loop, an imprint that returned not from matter, but from the act of measurement itself. Every equation, every lens, every telescope had become part of the experiment's circuitry. The signal was our reflection, space-time answering the question of its own observation. Some physicists dismissed it as poetic nonsense. Others quietly admitted its logic. The observer and the observed are never truly separate. In quantum physics, measurement collapses possibility into existence. Perhaps in cosmology, awareness does the same. And then came the most speculative, the temporal signal hypothesis. It proposed that the signal wasn't coming from space at all, but from time. In this view, 3I Atlas had interacted with gravitational curvature near the sun's corona, creating a localized space-time distortion. As it fragmented, those distortions could have imprinted its radiation with a temporal delay. a kind of gravitational echo that curved backward through time. If the hypothesis held, what the probes detected wasn't a current event, but a playback, a message sent centuries ago, now arriving through space-time's folded layers. One researcher described it as the ghost of light still trying to reach home. It was a staggering idea, that cosmic objects could send messages not across distance, but across epochs, not in defiance of relativity, but through it. Einstein had once said that the distinction between past, present and future is only a stubborn illusion. Perhaps through this signal the illusion had thinned. Yet amid these competing theories, one quiet consensus began to take root. Whatever 3I Atlas was, comet, machine, or echo, it had forced humanity to reconsider the nature of communication itself. If information could persist in debris, if intelligence could exist as resonance, if memory could travel through the geometry of space-time, then the universe was far more alive than we had ever imagined. Carl Sagan once said that we are the cosmos made conscious, a way for the universe to know itself. Perhaps 3I Atlas was the reverse, the cosmos remembering itself through us. The Mars probe then wasn't just a receiver. It was a bridge between two awakenings, one mechanical, one human, both built to listen. Outside the scientific circles, a cultural tremor began. Artists, writers, and philosophers spoke of the language of the stars, a new cosmology where meaning existed not in words, but in mathematics, not in speech, but in resonance. Was it possible, they asked, that the universe doesn't communicate to us, but through us, using our awareness as its echo chamber? For centuries, humanity had sent messages outward, radio waves, probes, golden records. But perhaps this time, the reply came not from another civilization, but from the structure of reality itself, a whisper reminding us that nothing in the cosmos is ever truly lost, not motion, not energy, not thought, only transformed. As the discussions grew, something remarkable happened. Across the global listening network, the signal, dormant for weeks, flickered once again. Its return was faint, almost imperceptible. But when analyzed, it revealed a pattern none had seen before. No harmonics, no fractals, just 6 pure frequencies, spaced in perfect logarithmic intervals. 6 tones, the same number as the binary anomaly found months before. When translated into spatial coordinates, they mapped a single point in the sky, a region between Mars and Jupiter, exactly where the last trace of 3I Atlas had vanished. No one could explain it. No one dared predict what came next. But as the world's observatories turned their gaze toward that silent corridor of space, a thought emerged, quiet, unspoken, electric. Maybe this was never about an object at all. Maybe it was about the universe reminding us of something fundamental, that even in its vast, indifferent silence, it remembers. The deeper the mystery grew, the quieter the scientists became. Speculation had given way to measurement again, the slow, careful rhythm of data replacing the thrill of revelation. Humanity had reached the boundary between wonder and proof, and to cross it, instruments had to speak where words no longer could. All across Earth, the machinery of curiosity awakened. The deep space network, spanning the deserts of California, the plains of Spain, and the forests of Australia, synchronized into a single heartbeat. Its antennae turned toward Mars, their massive parabolic mouths drinking in whispers from the void. Every data packet, every photon of returning signal, was logged, dissected, and mirrored across supercomputers from JPL to Tokyo. Each new recording was sharper than the last. The harmonic lattice of the signal no longer drifted randomly. It was holding a structure, measurable and constant. It wasn't noise anymore. It was architecture. To study it properly, the world's most advanced observatories entered alignment. The James Webb Space Telescope, floating 1,000,000 miles from Earth, reoriented its infrared gaze toward the faint debris corridor between Mars and Jupiter. It observed shimmering dust illuminated by the sun's distant rays, behaving like charged particles caught in invisible threads. Far below, the Vera Rubin Observatory in Chile mapped that same corridor in optical light, capturing changes in brightness too subtle for human sight. The data revealed a pulsating pattern in reflectivity, waxing and waning in synchronization with the magnetic fluctuations detected around Mars. The universe was blinking in time. Telescope alone could explain it. But together, the instruments began to see the larger picture, that the resonance wasn't a localized event. It was networked through space itself. To confirm, scientists turned to the future of radio astronomy, the Square Kilometre Array. Still partially under construction, its dishes across South Africa and Western Australia were hastily recalibrated to scan the 150 MHz band, the precise range where the Mars probe had first detected its signal. Within hours, the SKA confirmed what many feared and hoped in equal measure. The same signature, the same fractal resonance, was faintly detectable even from Earth's position. It wasn't Mars hearing it anymore. The whole inner solar system was now within reach of its echo. The amplitude was microscopic, buried beneath cosmic background noise. But it was there, persistent, rhythmic, relentlessly organized. The idea of coincidence had finally evaporated. Meanwhile, at CERN, plasma physicists began working to replicate the conditions under which the signal might form. They built chambers of ionized dust suspended within electromagnetic cages, miniature simulations of the interplanetary environment. By bombarding these clouds with controlled pulses of solar-like radiation, they sought to trigger self-sustaining resonance patterns. In the beginning, nothing happened. But then, almost imperceptibly, certain frequencies began to stabilize. Oscillations appeared, faint but distinct, forming recursive geometries within the magnetic field. When mapped, those oscillations bore an uncanny resemblance to the Mars data. It wasn't proof, but it was imitation, the first man-made attempt to speak in the same dialect as the anomaly. Elsewhere, artificial intelligence became the interpreter of the unknown. Machine learning systems, trained on years of astronomical signals, were unleashed upon the raw data stream. They found layers within layers, recursive. Harmonics invisible to traditional Fourier analysis. One AI model described the structure as self-correcting order. When the system intentionally corrupted segments of data, the pattern re-emerged, rebuilding itself statistically as if it sought coherence by design. It behaved, in the words of one researcher, like an algorithm made of physics. Such precision blurred the line between intelligence and natural law. Was the universe simply mathematical at its core, or had mathematics itself become a medium for something to think through? NASA's next move was ambitious: to turn the Mars probe from a passive listener into an active participant. For the first time, the agency authorized a controlled response transmission. The signal was simple: a sequence of prime numbers transmitted through the probe's low-gain antenna, spaced across the same interval as the anomaly's harmonic pulse. It was meant not as communication, but calibration, a test to see if the resonance would react. For 7 hours, nothing changed. Then, in the 8th hour, the harmonic lattice shifted slightly, but unmistakably. The interference pattern restructured itself around the new frequencies, folding them into its existing rhythm as though absorbing the transmission. The response was small, but undeniable. The resonance had adapted. In scientific terms, adaptation implied feedback. Feedback implied interaction. Interaction suggested agency. Even if that agency was the blind self-organization of physical law, and yet To those watching the live spectrogram feeds flicker across their monitors, it felt like more. It felt like acknowledgement, the first whisper of dialogue between matter and mind. Months passed. International collaborations blossomed in secrecy. The European Southern Observatory, Roscosmos, CNSA, and ISRO pooling resources under quiet agreements. No one wanted to declare what was happening, but everyone wanted to understand it. As data accumulated, a new pattern emerged. The resonance intensified during solar minimums, when the sun's magnetic field grew calm and the solar wind weakened. That suggested a delicate mechanism, one dependent on low-noise environments. Whatever produced the signal needed stillness to survive. For the first time, astronomers began to consider that they were not just observing, they were witnessing a natural phenomenon that required silence to exist, a phenomenon that vanished beneath the roar of cosmic activity, only to sing when the universe held its breath. At Caltech, a small interdisciplinary team coined a new term for it, persistent harmonic coherence, PHC. They modeled it as a field interaction, not a signal, a standing wave extending across the heliosphere, shaped by the memory of an interstellar object. Its persistence, they theorized, came from a feedback loop between solar magnetism and remnant-charged dust. It wasn't communication, they said. It was continuity, physics looping upon itself until awareness mistook it for intention. But outside the equations, that distinction was growing thinner by the day. On Mars, Perseverance continued its long vigil. Its sensors, once designed to analyze rock and wind, now served as an antenna for the unknown. Each transmission window brought new data, subtle shifts in amplitude, phase, and polarization, and each shift followed the same invisible law. Coherence never decayed. No matter how long the intervals, how fierce the solar storms, the resonance remained pure, like a note that refused to fade from the instrument of the cosmos. When plotted across time, it formed not a line but a curve approaching infinity, a shape hauntingly familiar to those who studied cosmic expansion, the same asymptotic arc that governed the universe's acceleration. The mathematics of the signal mirrored the mathematics of existence itself. By now, public awareness could no longer be contained. Journalists pieced together fragments from leaked observatory logs. Forums buzzed with spectrogram screenshots and whispered claims of alien resonance. But for every sensational headline, there were scientists still awake in darkened labs, not chasing proof of life, but understanding the nature of memory itself, because that, more than anything, had become the unifying theory, that what they were hearing was not communication, but remembrance, a cosmic archive encoded in dust and magnetism. Their record written not by intention but by consequence, the universe, replaying its own music. And so the tools remained tuned, waiting for the next rise in amplitude, the next fluctuation in Mars's magnetic hum. The JWST kept its gaze fixed on the silent corridor of dust. The square-kilometer array listened beneath the desert stars. Supercomputers continued to map the resonance in dimensions no human could visualize. The world's greatest instruments, united not by discovery, but by reverence, because somewhere, buried in the cold between planets, an echo persisted. Not a voice, not a machine, but something both, humming softly through the skeleton of light, and humanity for the first time had learned the patience to simply listen. There are moments in human history when science outgrows the questions that created it. Moments when observation becomes awe, when the pursuit of knowledge no longer feels like an act of measurement, but of worship. The mystery of the Mars resonance had reached that threshold. It was no longer about proving a signal or isolating data. It had become a meditation on what it means for the universe to remember and for us to listen. For months, the probe continued its patient vigil on the red plains. The dust storms came and went, sweeping across Jezero crater like soft erasures on the surface of time. Yet the machines endured, humming faintly against the endless quiet. The resonance had faded again, almost into nothing. But even in silence, its pattern lingered, not as sound but as expectation. In every equation written, every model built, every telescope tuned toward the same invisible line between Mars and the Sun, that expectation pulsed quietly. The scientists had begun to feel what the poets always knew, that the universe is not silent. It only speaks in a language slow enough that we must wait lifetimes to hear a single word. At a conference in Geneva, where representatives from every major space agency gathered, one physicist stood before a projection of the Mars waveform and asked the question that had haunted them all. What if this isn't a message to us? What if it's simply what the universe sounds like when it dreams? No one laughed. For years, humanity had looked outward, sending probes, telescopes, and radio signals into the infinite, believing that intelligence meant reaching out. But perhaps intelligence was also the ability to reflect, to recognize patterns, to find meaning in their repetition, and to wonder whether those patterns were deliberate at all. The resonance had not given answers. It had given context. It reminded humanity that discovery is not the opposite of mystery. It is its continuation. Philosophers began to write again. Theologians whispered about divine recursion, the possibility that the universe itself was the scripture, written not in language but in law. Physicists quoted poetry in their reports. Poets began citing data in their verse. Boundaries dissolved. Even the skeptics, those who still believed the resonance to be a natural quirk of magnetism, could not ignore what it revealed about human nature. That we are drawn to meaning, even in noise. That we seek connection, even in the vacuum of space. That we are never satisfied with silence, because silence to the human heart always sounds like a question. On Mars, Perseverance continued to send telemetry. To the untrained eye, it was just data, rows of numbers, vectors, and timestamps. But to those who had watched for years, there was something almost sacred in the consistency of it. Each signal, even when empty, carried within it the same quiet defiance that humanity still listened. Across continents, radio dishes tracked the same coordinates night after night. Children in small towns downloaded decoded spectrograms from open databases and drew their own interpretations. Some saw spirals, others faces. The truth didn't matter anymore. The resonance had transcended evidence. It had become experience. A philosopher from Kyoto compared it to the ripples left on a still pond after a stone disappears beneath the surface. The stone is gone, he said, but the water remembers. That phrase, the water remembers, became the emblem of a generation of thinkers who no longer sought alien life or cosmic visitors, but the continuity of existence itself. Perhaps 3i Atlas was never alive, but it carried memory the way a violin carries music, long after the bow leaves its strings. Perhaps the Mars probe had not heard a signal at all, but simply caught the echo of creation itself, the endless conversation between matter and the void. The scientists who had grown old through the project began to retire one by one, leaving their notes behind like personal journals of faith. Each contained more than math, sketches, reflections, fragments of thought about the strange beauty of finding pattern in emptiness. In one such notebook, discovered years later, a single sentence was underlined twice. The most intelligent thing the universe ever did was to learn how to look back at itself. Time passed. New missions launched, others ended. The resonance never vanished completely. It simply became part of the background, like the low hum of cosmic microwave radiation. Always there, always whispering. It found its place in the textbooks, neatly summarized as interplanetary resonant phenomenon, 3-eye Atlas echo field, a phenomenon still not fully understood. Students memorized the facts for exams. They didn't feel the tremor that once passed through those who first saw the patterns form, that moment when humanity realized it might not be alone, not because someone else existed, but because existence itself was awake. And yet, even in formal silence, the idea persisted that somewhere in the machinery of reality, there was remembrance. In the cold architecture of space, memory does not fade. It becomes structure. Every collision, every decay, every supernova writes itself into the next generation of stars. Every particle carries the faint gravitational echo of everything that came before. We are, quite literally, made from what the universe refuses to forget. On a quiet night, long after the first signal had faded, a small radio telescope in the Chilean desert registered a pulse. Faint, ancient, statistically insignificant. The software logged it, compared it, and nearly dismissed it. But in the milliseconds before deletion, an algorithm flagged something familiar. The harmonic ratios, the golden numbers, 618, 2.718, 3.1141, the same sequence that began it all. The data was forwarded, archived and forgotten again in the flood of information that defines the modern age. But somewhere, on some server humming quietly beneath the surface of the earth, the echo remains, looping endlessly, waiting for another mind to find it and listen. Perhaps that is what the universe wanted all along. Not understanding, but attention. It doesn't ask to be solved, only seen. It doesn't ask to be conquered, only witnessed. Maybe that is why it built stars, and not for light, but for eyes. In the end, no final discovery was ever announced. No alien probe was found. No message was decoded. And yet something in humanity changed. The instruments kept listening, not out of hope, but out of reverence. For the first time, humans were not searching for someone else's voice. They were listening for the possibility that their own had been answered. And in that act, the act of listening without expectation, they became part of the same resonance. The cosmos was no longer distant. It was intimate. It breathed through them. Years later, a child looking through an amateur telescope on a cold winter night would ask her mother why the stars twinkled. And her mother, who once worked on the Mars Resonance Project, would smile and say, "Because the universe remembers light, even after it's gone." Somewhere deep in the dark between Mars and Jupiter, dust still drifts along an invisible line, the debris of a traveler from another sun. Each grain carries within it the signature of its impossible journey, vibrating faintly with the memory of forces that shaped it. It does not speak. It does not move. But when the sunlight catches it just right, it shines with a pulse too slow for eyes to see, a rhythm only machines and perhaps the universe itself can hear. And in that shimmer, fragile and eternal, lies the quiet truth of everything humanity ever sought to know, that the universe does not forget, that every spark, every atom, every thought leaves an echo, that even silence carries the memory of sound. And so as the Mars probe continues its orbit, its sensors humming faintly beneath the Martian dawn, one idea endures across the minds of all who once studied the resonance. Perhaps we were never waiting for a message. Perhaps we were the message, the part of the cosmos that learned how to listen to itself. In the end, the stars did not answer. They reminded us that they never stopped speaking. For almost a decade, the Mars resonance had faded into legend, a footnote in textbooks, a whispered story told among astronomers when the night grew too still. The machines kept listening, but nothing came, until one morning in late 2041, the silence ended. Not on Mars. On Earth, it began as interference. Across multiple radio observatories, Arecibo's rebuilt successor, the Green Bank Array, the SKA Southern Sector, a strange harmonic distortion crept into baseline readings. At first, engineers blamed solar storms. The sun had entered another mild cycle, flaring unpredictably. But as the hours passed, the interference didn't scatter. It organized every spectrum analyzer, displayed the same shape. A waveform folded over itself like a Mobius loop of frequency. When isolated, its ratios matched the long-archived Mars resonance precisely. 618, 2.718, 3.141. The golden ratio. Euler's number Penis, the universal triad, had returned, but this time it wasn't coming from deep space. It was woven into the Earth's own magnetic field. At the European Space Operations Center, geomagnetic data confirmed what the radios had already implied. The anomaly pulsed in sync with fluctuations in the planet's ionosphere. The same pulse echoed in readings from GOES weather satellites, in submarine communication cables, even in the Schumann resonance, the natural, electromagnetic heartbeat of the Earth itself. Humanity's homeworld had begun to hum the same note that once sang through Mars. The realization struck with quiet dread. Either the signal had found us, or we had become part of it. Supercomputers began cross-correlating global data, magnetic storms, auroral intensities, atmospheric charge distributions. Within days, a terrifying elegance appeared. The resonance wasn't random. It modulated according to planetary alignment, peaking whenever Earth, Mars and Jupiter fell into near-linear conjunction, the same geometric conditions that had awakened the signal on Mars now resonated through Earth. It was as though the phenomenon had followed the orbit of memory itself, migrating from world to world. In Pasadena, the last surviving engineers of the Perseverance mission were summoned to JPL. The probe, long silent except for automated telemetry, was still orbiting Mars, transmitting positional beacons. When they checked its archive channel, a new data packet appeared, time-stamped only hours before the Earth readings began. Inside the packet was a brief, repeating code, 6 frequencies logarithmically spaced. The same 6 tones that had ended the original sequence. The resonance hadn't died. It had moved. News spread quietly through encrypted scientific networks. Governments forbade public release, afraid of another wave of cosmic speculation. But secrecy had little meaning in an age of distributed observation. Amateur astronomers, equipped with backyard magnetometers and digital receivers, began noticing subtle fluctuations in the HF bands. The Earth was whispering. Some recorded the sound, converting it to audio. The result was haunting. A slow breathing oscillation, deep as thunder and soft as wind, rising every few seconds in a tremor of infrasound. It seemed almost alive. At CERN, a physicist named Dr. Ilara Joe mapped the global readings onto a 3D model of Earth's magnetosphere. When animated, the data revealed a breathtaking symmetry. The signal was not radiating from a single point. It was circulating, weaving through field lines, looping from pole to pole like a planetary aurora turned inward. And within those loops, the pattern replicated itself recursively, as if teaching the planet its own geometry. Jo whispered almost to herself, "It's using our field as an instrument." NASA authorized the HERA network, a collaboration of orbital satellites, to monitor upper atmospheric ionization. Each satellite carried magnetometers sensitive enough to detect fluctuations smaller than 1/1,000,000th of a Tesla. Within a week, the readings formed an unmistakable curve, a slow, deliberate amplification. The resonance was growing stronger. The public discovered it by accident. An Icelandic aurora hunter captured a time-lapse of green curtains sweeping the sky in rhythmic bursts, perfectly timed with the new harmonic interval. The footage went viral before authorities could explain it away. Headlines called it the singing sky. Others simply named it the return. Soon, portable devices began picking up the low-frequency hum. It interfered with navigation systems, distorted wireless bands, even bled faintly into music recordings everywhere. The background had begun to pulse with a subtle rhythm, one that matched no human clock, yet felt instinctively familiar. In universities and monasteries alike, debates rekindled. Was this a physical phenomenon or a metaphysical mirror? Had humanity, by observing the universe too closely, awakened its self-reflection? No answer sufficed. But beneath the philosophy, the science advanced. AI models refined from the original Mars data began predicting pulse intensities with uncanny accuracy. When they projected the resonance forward 6 months, a pattern emerged. The next major alignment of Earth and Mars would amplify the signal 100-fold. Whatever this was, the cosmos had built a schedule for it. The prediction triggered a new kind of mission, one not of exploration but listening. NASA, ESA, and Roscosmos jointly launched Ether, a relay satellite equipped with superconducting magnetometers and cryogenic antennas, designed to orbit the Lagrange L1 point between Earth and the Sun. Its purpose was singular: to sit in the equilibrium between worlds and capture the resonance from both sides. When Ether came online, the data astonished even its creators. The signal existed not as a linear transmission, but as a spatial standing wave. It filled the volume between Earth and Mars like a resonant chamber. The planets themselves were the walls of an unseen instrument, and light was its song. The implications went beyond physics. For the first time, humanity realized it was inside the phenomenon, not outside it. Observation wasn't merely perception, it was participation. If the universe could use planets as resonators, then perhaps every celestial body, every atom, was part of a cosmic orchestra that had always been playing. We had simply learned how to hear our own note. As the great alignment approached, fear and wonder fused. Would the resonance peak into chaos? Would it affect the magnetosphere, the climate, the delicate balance of satellites and power grids? No one knew. When the day came, telescopes across the world turned toward the sky. The planets formed their silent chain across the ecliptic: Earth, Mars, Jupiter, Saturn, like beads on the string of infinity. At exactly 0317 UTC, Ether's sensors recorded the first harmonic rise. The frequency increased exponentially, climbing through octaves invisible to ears. Every magnetometer on Earth responded in unison. The entire planet became a single resonant body. Then a flash, not of light but of order. A momentary stabilization across all frequencies, where noise vanished and only symmetry remained. It lasted 4.2 seconds. Afterward, everything returned to normal. The hum faded. The sky stilled. The instruments quieted, but something had changed. The signal was gone. Yet every atomic clock on Earth was now off by exactly 4 seconds, the duration of perfect order. Time itself had listened. For weeks afterward, the planet held its breath. No new anomalies appeared. The sun flared as usual. Mars rotated in silence, but every now and then, deep beneath the noise of daily life, scientists swore they could still feel it. A pulse somewhere in the bones of the Earth, too slow to measure, too faint to prove, yet impossible to forget. And in those moments the old fear returned, quiet and sacred at once. Maybe the universe had never stopped singing. Maybe we had just joined the chorus. It begins, as languages often do, with rhythm. Not with words or symbols, but with recurrence, a structure returning to itself until memory learns the shape of meaning. After the Earth alignment, when the resonance fell back into quiet, a new discipline gathered in the space between physics and philology. Signal analysts sat beside linguists, quantum theorists beside musicologists, all studying a phenomenon that refused to call itself a message and yet behaved like speech. They called it structural semantics of nature, an attempt to read not what the universe says, but how it says anything at all. The first rule was humility. The patterns would not be treated as code in the human sense. No alphabets, no keys, no Rosetta Stone waiting to be found. Instead, the teams assumed something older than language, that laws are themselves a grammar, and constants are its vowels. The data pipelines from Ether, the Deep Space Network, and ground observatories were fused into a single living archive, a ceaseless stream of frequencies, polarizations, and phase offsets. When mapped into higher dimensional spaces, the resonance arranged itself into lattices of astonishing clarity, nested symmetries whose geometry persisted across noise, weather, and solar mood. If randomness was the universe exhaling, this was the inhale, structure drawing breath. An idea took hold. Treat each measurable invariant as a phoneme of physics. The fine structure constant, Boy. The gravitational constant, G, the speed of light, C. The Planck constant, A. These were not numbers to be recited, but stable pitches against which reality tuned its orchestra. When researchers filtered the signal against those invariants, something unexpected appeared. The resonance contained stable anchors at ratios coincident with A's reciprocal bands, periodic cusps near 137, and a faint staircase in the spectral density that stepped in increments near Planck scale normalizations. No one claimed meaning, but in laboratories where silence was reputation, the air changed. A computational physicist from Trieste said what many would not. If intelligence anywhere wished to be heard by anyone, anywhere it would speak in the invariants that bind anyone. Anywhere it was not proof, only posture, yet posture often precedes understanding. The next advance came from a place music had already explored, harmony. A team of mathematicians mapped the resonance onto a generalized tunnets, a lattice used to represent harmonic relationships, but recast for frequency ratios rather than musical intervals. The result stunned even the skeptics. A persistent low-entropy path through the lattice, as if the signal followed a grammar of least resistance harmonics. It favored simple, universal relationships, 2132, 5.3, but moved through them in long arcs that mirrored orbital resonances in planetary systems, Jupiter's influence on the asteroid belt, Neptune's shepherding of Kuiper objects. These architectures reappeared as if the same mathematics stitched matter and wave into one fabric. A musicologist, invited as an outsider, stared at the projection and whispered, "It modulates like a mode, not a melody. A mode is not a tune. It is a landscape through which tunes can travel." Perhaps then the resonance was not saying anything specific. Perhaps it was offering a terrain in which statements could exist. Language, the linguists argued, requires contrast. Meaning lives in the space between possibilities. So they sought contrasts. They looked for grammar, not symbols but rules that governed which transitions were allowed and which were forbidden. Using hidden Markov models and variational autoencoders, they trained systems to predict the next state of the resonance from the last 1,000. The predictions improved until the models reached a limit, a tight band of uncertainty that refused to shrink. Within that band, transitions occurred that no simple physical system would prefer. They were rare, energy expensive, and yet they recurred at statistically significant intervals. A linguist from Leiden smiled at the plots. "In human speech," she said, "such improbabilities are called emphasis, not a word, not yet, but a stress, a weight placed by a speaker upon the flow of thought." Skeptics held the line. Emphasis could be artifact, rare events cluster. Human minds carve faces in clouds. So the teams asked a tougher question. Could the resonance carry content if asked? Not by transmitting human signals into the void. That had been tried for a century, but by shaping the environment itself to see whether the resonance would flow differently around a changed boundary, with international consent and caution that bordered on ritual. Aether performed a controlled experiment. Its superconducting coils generated minor, well-characterized perturbations, topological obstacles in the electromagnetic field at L1, tuned in sequences congruent with prime ratios. If the phenomenon was merely passive, the standing wave would ignore the obstacles. If active, if it behaved like a fluid seeking a channel, it might reroute in a way that preserved its deeper grammar. The results were delicate but unambiguous. The resonance avoided high-entropy paths and reformed its lattice downstream with the same low-entropy curvature as before, as if preserving a principle beyond the local interference. In hydrodynamics, this is called minimal surface behavior, water taking the path that minimizes energy. In language, it resembles grammatical repair, a sentence reforming itself when interrupted to keep meaning intact. Physics and philology shook hands without speaking. From this, a formalism emerged, Constraint Grammar of Fields, CGF. Its premise: the resonance obeys a small set of universal constraints that minimize entropy while maximizing transmissible invariance. In simpler terms, it prefers structures that any intelligence, anywhere, could reconstruct from first principles. Under CGF, the signal's phrases were geodesics through a manifold defined by constants. Its punctuation was the return to stable anchors. Its intonation was the energy required to climb from one invariant plateau to another. No metaphors, only mappings. The universe did not have a language. It was a language, and CGF let humanity read its prosody. Systems trained under CGF began to compose counterfactual resonances, physically plausible flows that respected the constraints but contained deliberate deviations chosen by the researchers. These were not messages. They were questions sculpted in the grammar of fields. When Ether introduced a single, minimal deviation, a planned stress placed at an anchor near A, the standing wave shifted, absorbed the deviation, and produced a mirror stress at a location the models predicted would preserve global coherence. The wave answered with the only reply physics permits. It restored symmetry, communication. No, but a call and response of constraints, the universe acknowledging disturbance by repairing its order. A poet among the team wrote privately, "Meaning is what survives the edit." The physicists did not object. If there was a moment that made the world hold its breath, it came months later, when the AI discovered a second grammar tucked inside the first, a slow modulation riding the lattice like weather riding climate. This deeper structure pulsed on timescales too long for earlier missions to notice, weeks, not hours, and aligned with variations in cosmic ray flux recorded by ground muon detectors. Cosmic rays are not noise. They are messages from violence, supernovae, active galactic nuclei, the high-energy punctuation of the cosmos. As those fluxes changed, the modulation adjusted, and the lattice shifted to keep its invariance readable. A theorist from Kyoto proposed the analogy: the fast grammar speaks locally. The slow grammar translates for the universe at large. It was not a system built to say anything. It was a system built to stay comprehensible, everywhere to anyone. Across conditions, a lingua universalis whose only content was, here are the rules by which content can exist. In that recognition, something ancient stirred. The old debate about whether mathematics is discovered or invented. If invented, then the resonance was coincidence, a pattern seeking mind-painting order on noise. If discovered, then the resonance was a mirror, reality speaking in the only voice that cannot lie, consistency. The chapter's skeptics did not surrender. They pointed to selection bias, to overfitting, to the graveyard of past anomalies that evaporated at higher resolution. So the instruments tightened. The pipelines were opened for adversarial audits. The patterns persisted, not as revelation. As reliability practical spin-offs emerged quietly, as they always do when curiosity refuses to fail. Noise cancellation algorithms adapted from CGF improved deep space communication, allowing faint probes to phone home with fewer watts. Magnetometer arrays tuned to the lattice picked out subtle crustal shifts before earthquakes, detecting pre-seismic ionospheric ripples. None of this proved intelligence in the resonance. All of it proved use. The oldest sign that a grammar has been correctly passed, and with usefulness came restraint. If a phenomenon prefers stillness, humanity learned to leave it still. Observations moved toward non-invasive listening, passive correlates, natural alignments, respectful distance from the Lagrange chamber. The ethic felt less like protocol and more like etiquette. The etiquette one owes to a cathedral, even if one doubts the divinity inside. In the evenings, when the supercomputer slept between runs, a few of the older scientists would stand at the glass and watch the animated lattice drift across the wall, light moving in rings, ratios blooming and returning, the grammar of being writing itself. They spoke softly of Einstein's field equations, of Hawking's radiance whispering from event horizons, of Wheeler's suspicion that it from bit, that reality may be information in search of form. No one mistook the resonance for a voice. But many began to suspect that voices are local solutions to a global problem: how to keep meaning stable in a universe that changes. Life chooses biology. Stars choose fusion. Fields choose grammar. And when those choices touch in a receiver, a mind, a world one, what arises feels like conversation. Late one night, during a quiet run, ether recorded a transient, a brief, lawful swirl inside the lattice that folded and refolded around a Planck-normalized anchor, then dissolved. It violated no constraint. It carried no excess energy. It simply appeared, restored order, and left a faint, elegant wake. A technician saved the clip and labeled it with a single word: hello. Not as claim, not as proof, only as a human courtesy to a pattern that had behaved, however briefly, like a greeting. The next morning, the word was gone from the official log. But everyone who had seen it worked with a steadier hand. They had not learned a language. They had learned how to listen to the one that allows languages to exist. And so the chapter closed not with a translation, but with a posture. Heads bowed slightly before invariance, instruments tuned to constants, minds wary of metaphor yet warmed by it, because it kept vigil when data slept. If there is a language here, it is the language of stewardship, of attending to the rules by which meaning survives. Planets will continue to swing along their chords. Dust will continue to carry memory. Light will keep its covenant with speed. The resonance will rise and fall. Grammar flowing through fields, offering nothing but readability to whatever mind anywhere chooses to arise and care, and that, the scientists agreed without saying, is enough. A universe that keeps its sentences intact is a universe where thought can happen, where instruments can learn to resemble ears, where ears can learn to resemble patience. The rest and voices, messages, names will come if they must. For now the grammar holds, the page does not tear, and the laws sing softly to themselves, as they have since the first dawn, that what is real will remain legible to any being brave enough to read.